Thank you. So, this was a really kind introduction. Yeah, I'm here to speak about distributed tracing because I spent the last year kind of wrapping my head about distributed tracing, around OpenTracing, and how all this stuff works. I spent the year instrumenting our applications, and and sharing what I learned. So this is a kind of presentation about few questions that I got about tracing that I think can be helpful to be answered all together. So I'm Gianluca Arbezzano. I'm an SRE at InfluxDB, and you can find me on the internet. Other than coding and make dirty hacks that look awesome, I grow my vegetables, so I have a garden. I like to grow my gardens, and I travel for fun and work. So that's it. InfluxDB, I feel at home at the open source monitoring conference because my company provides a set of open source tools to spin up a monitoring system. So the most famous one is probably InfluxDB, that it's a time series database. It's in Go, so it's a single binary. You spin up the time series and you start to insert points and events inside it. After that, we discovered that there are more needs, and storing data is not enough. So what we released was Telegraph, that is an agent that you can install in all the servers, and it collects data. So there are a lot of input and output plugins, so you can use Telegraph even with other databases like Graphite or CloudWatch or Stackdriver. There are a lot of output plugin and input plugin. So there are more than 100 input plugins that you can use, so you can scrape data from almost everything. And it's open source, so if something is missed, it can be coded. And another project is Capacitor. Capacitor is our downsampling and alerting system. So it's a way to proactive do something with your data, because as you probably know, data are just data. We need to make them useful in some way. So Capacitor is our way to proactive take action on the data. The alert is just one of the possible things that you can do with the data. Chronograph is an alternative to Grafana, to what we saw, and it's a dashboard. It's a dashboard that, other than providing graphs, it also helps you to visually manage all the tick stacks. So you can build alerts, or you can see where your telegraphs are, and all this kind of stuff. But it also works with Grafana, so play with what you want. So the first question, why do I need distributed tracing? And this is a good question. Thank you for raising that. Well, the first issue is that a few years ago, we had this monolithic application, or even if it wasn't a monolithic, it was not that distributed as we have now. So now we have microservices, or in general, we have more requests that are going through the network, inside our network. And also, we use a lot more third-party services. For example, probably you use Cloud0 to manage authentication. It's a really powerful as-a-service tool to manage authorization and authentication. Or you have other systems that you integrate with. So all this stuff that are going out from your application needs to be in some way monitored, and they have a gravity on your system because it makes everything more complicated. So we need distributed system to describe the distribution complexity. And the distribution complexity is a lot more now that we have microservices or cloud environment and this kind of stuff. So that's why we need distributed tracing. In practice, what you still have a set of points or logs. It's just a different aggregation of these points. So a trace is made of points, the start and the end point, and there are other points that describe what happened in the middle. But it's just a different aggregation with logs and traces. So nothing really new. And as I said before, they tell you the story of your distributed system. How a trace looks like. If you never saw a trace, but you probably did, because a trace is when you are profiling an application and you get the profile page with all the lines and all the functions, that's a trace. Or when you are inspecting in a web page in Chrome and you are in the Chrome development tools, you just see a trace of all the requests that are going out from your browser. So that's a trace. A trace is made of span, so every single line is called span, and it's the smallest unit that we use to describe trace. A span is used to describe HTTP request or a database query. If you interact with MySQL, maybe a query is a span. A single message executed in a queue system. So when you put a message in the queue and the worker pick up that message and execute the message, that can be described as a span. So obviously, if your queue retries, you have a lot more spans because it keeps creating new one. Or when you look up a key value store, a key from a key value store. So usually a span has a span ID. And it is unique inside a trace. It has a trace ID to group together spans that come from the same request, usually. It has a parent ID because it helps you to build a hierarchy between spans. It has labels. Labels are metadata that you attach to every span, and it gives you more information about what it's doing or what it did. For example, if you're instrumenting, as I tell you before, if you're instrumenting a queue system, probably one of the labels can be the message itself or part of the message. If you're instrumenting, there is a popular use case that Twitter released that they was hitting a bug with their cache system and they wasn't able to understand when the cache was hidden and when it wasn't. So they traced that part and they discovered that for some key, they wasn't eating the cache as it was supposed to be. So it's also another possible use case. And the label, in this case, can be the key, the lookup key from the cache. Other than labels, we have another key value pair that is called a span context, but in particular, a span context is propagated through the network. So as I told you, it's a distributed tracing. So in some way, the information need to go from the service A to the service B. They usually go over a network. So the span context is propagated through the network. And obviously, logs can be part of the span. I will show you how it can be done, but in the simple stuff that you can do is that you create your logger and you put the trace ID inside every line. So you can grep for the trace ID, and you can have trace and logs and match them together. So this is the easy stuff that you can do, and that's what I do. This is a trace. So a span is the smallest unit that we can have, but a trace it's what we are looking for. So every line is a span, and we have the list of services that we are hitting. In this example, I simulated a HTTP request. So usually you have Nginx or your Ingress proxy, and you have service A that probably reached to a MySQL, and maybe you have also a worker. So this is a representation of a trace. The Nginx is the biggest span because in this case, I don't return any request until everything is done. So we have the longest span there, and you have your application SA that has an handler that is the create user, so it's your API. And what it does, it checks if the user already exists on MySQL. So the first line, the user exists, is a query. And it inserts the user if it doesn't exist. In this case, it inserted it. And it sends an email using a word queue. So this is what you can get tracing an application. That's the idea. As I told you, there are labels and times and duration. So what you get in a span is the service name, so the service that generated the span. You have the trace ID, that is a unique value, and you have a span ID that is unique inside the trace ID. And you have the span name, so user exists. You have the duration, so how long it took, and the start time. So in this way, you can build the graph that we just saw. Obviously, label, I took the user exists, so probably you can put as a key value the query. So you have the query inside the span and the user that made the query. So this is just a prototype, let's say. How do I follow a request? Obviously, it depends on your application, but one of the examples, you need to instrument your application. If you have a HTTP server, usually they get propagated via header. Same for gRPC, because gRPC, if it goes over TCP, it has headers, so you can use headers. And the same example, if you have a queue system, you can embed this data as a payload inside the message. So obviously, you need to try to decouple these two codes, the instrumentation code from the code for the business logic of your application, but that really depends on what operating languages what languages you are using or what framework you are using. For example, I develop in Go every day, so Go has this concept of middleware that probably Node.js also has. So usually you wrap the tracing code in a middleware that gets propagated into the application. If you work in a framework that is more event-based, like Zen framework in PHP or whatever, you can probably hook and attach to listeners in your requests. So the goal is to keep these codes like far from each other. As I told you, there are different ways to propagate headers. OpenZipkin is a project developed by Twitter in Java, and they put together this set of specs and rules to propagate headers that is called B-tree propagation, and a lot of tracers use and read it, so it's good to, if you're looking for something to study or to start with, it's good. Do I need a standard for tracing? You always need a standard, so the answer is yes. There is not enough standards, so that's how it is. But yeah, you need a standard or you need a protocol for at least two reasons. One, because other than having a distributed system and a microservices environment, we also write applications in different languages, and we don't work all in the same team. So in some way, even if we are so different or far from each other, at the end of the story, we need to build a trace. So to build a trace, we need to agree on the same protocol. So if it's a protocol, if it's a standard, you need something. If you use a widely supported standard, I will show you one of them later. Obviously, there is less vendor lock-in because you can switch between as a service or in-house tracers without re-instrumenting your application. This is important because instrumenting the application for tracing is not something that comes for free. It's something that you need to go and put in your code. So if you instrument all your application and it takes you weeks to do that, and at some point your vendor's is getting too much more expensive and you can pay it, you need to re-instrument your application. So if you adopt a standard or some bridges, it's going to be safer for you. So one of the widely adopted standard is OpenTracing. OpenTracing, it's an incubated project from the CNCF, so the Cloud Native Foundation, the same foundation that sponsors Prometheus, Kubernetes, CoreDNS, and a lot of other cloud projects that are cool these days. So OpenTracing tried to standardize trace. And a lot of this concept comes from what I showed you before. So you have the spans, and you have the parent span, the child spans, and you have the key value stored that are the labels. You have the span context. So everything works as I told you before. So you have a tracers, because obviously it's a standard, so you can have more than one tracers. There are open source, closed source, as a service solution. I'm going to show you some of them later. It's a widely adopted standard because Zenefit, GitHub, Giant, Twilio, Airbnb, Docker, and a lot of other companies and projects are using it already. And also, it is well supported. It is an open source community, so there are a lot of languages and a lot of frameworks that already implement this standard for free. So if you use gRPC, it comes from the OpenTracing SDK and capabilities. If you use Django or Python or whatever, there are libraries for almost every language. I put some example in Go because I develop in Go. So the idea is that in your main function, you ask for the OpenTracing library. This also works for the Java one or for the PHP one and the Python one, so the concepts are the same, just the language is different. But you have a global tracer, and that is the OpenTracing one. You inject the concrete one that you are using. So there are a lot of tracers around. You can use New Relic or Zipkin is open source, and as I told you before, Jaeger is another one in Go. Amazon X-Ray supports OpenTracing, Stack drivers. So there are tracers for a lot of services, and what you configure it and you inject it in the global tracer, and from this point in time, in your application, you just speak with OpenTracing API. It means that if tomorrow you need to use another tracer, what you can do is just with a feature flag or with flags, you can just change the entry point in the tracer that you are using to use a different one. So. The OpenTracing API looks like this. So you start a span. You can start a new span, or you can start a new span from a context. The context usually has already information about the trace ID and all this kind of stuff. So what you get is usually start span from a context, and you give the name of the span. So user exists or insert user that we saw before will be the operation name. And Go has this concept of defer that is executed when the function ends. So at the end of the function, when you are interested to end the span, you call the span finish. In the meantime, you can associate logs, or you can associate events or the label that we spoke about. So there are APIs that you can use to enrich the span with all the information that you are collecting. As I told you, you also have the ability to start child span. So you can start a span, you can pass the parent span inside, and you have a child span. Another, it's not a standard, this one, but it's called OpenCensus. It is sponsored by Google. It's a specification format for instrumentation libraries. So let's start from the beginning. It's a specification. So if you look at the repository, it's long markdown file with documentation about how it should work. And they also provide a set of libraries that implement the specification. So what you get is a library that you embed in your application, and it helps you to instrument your application. So you can push stats into the library, collect and aggregate metrics, and you can also push traces. So, and it works in the same way, with the same concept as OpenTracing. So you inject the exporter. It can be a log exporter, or an event exporter, or a tracing exporter. And from the back in your application, you just use the API that it provides. So it's an abstraction layer. How a tracing infrastructure looks like. If you're using OpenTracing, it looks like this. So you have all your applications. It can be just an application. It can be a micro application. It can be a Lambda function. It can be whatever you want. You have the code. You point the code to the tracer, and it gets the tracing stored. So tracer can be Zipkin, Jaeger, and whatever. Can I have a tracing infrastructure on-prem? Yes. There are open source alternatives too, like Zipkin in Java and Jaeger in Go. Jaeger is provided by Uber. Uber started it, and they donated it to CNCF. So if you are Go friendly and you're looking for Elasticsearch or Cassandra backends, you can use Jaeger. Zipkin is in Java, and it also supports MySQL, if you are a MySQL person. Obviously, all these tools have an abstraction, so you can implement an interface and have your storage tied to it, but it requires some work. There are other service tracing infrastructure. That's also a really good question, and it's also really important because when something gets wrong in your application, it's like the monitoring. If you tie the monitor too close to your application and it goes down with your application and your infrastructure, you won't know, so that doesn't really fit well in what you are trying to do. So outsourcing this kind of stuff is usually not a too bad idea. And yes, there are solutions. As I told you, New Relic is OpenTracing compatible. Honeycomb, that is a startup, observability startup, is also compatible. Like Steps, accept OpenTracing. And if you are on Amazon AWS X-Ray or Google Stackdriver, they both handle OpenTracing stuff. Can I store traces everywhere? Yes, at your own risk. So the problem with traces is that every request that goes to your system has a trace ID. And usually the trace ID is the one that you are using to look up the information. So you need to have that data, that information indexed for a fast lookup. So it means that the cardinality can be really high. Obviously, there are strategies. You can sample or you can instrument your application to not send all the traces from all the requests. So think about if you're using a load balancer, usually a load balancer use an entry point to check if everything is fine. And it calls your application every 10 seconds, every whatever. So if you trace every time that request can be useless. So what you can do is probably, a lot of tracers assumes that there is a header that says this trace that doesn't need to be stored. So maybe you can tweak your instrumentation library to do that. And obviously, databases with high write throughputs are better. So usually a lot of people use Cassandra or MongoDB because it can handle a lot of writes. And so yeah, you can do whatever you want. Zipkin by default starts with an in-memory database. So if you have a lot of memory, you can use that. But yeah, it's expensive. So that's it. Before moving, I'm just going to show you this small. This is a trace that comes from, I was debugging before coming here, so this is one of the traces I have. I developed, in InfluxDB we have a SaaS offering, so we have a provisioner and orchestrator that spin up stuff in AWS. So what I do, I instrumented this flow with OpenTracing. So as you can see, there is a HTTP request where you can see that there is a URL, so this is the front of my application. And I made a reactive planning, so I have a bunch of steps that get executed by a scheduler. So the first step is mark as pending, so it gets my clusters and it says, okay, this cluster is in a pending state, and it stores it to etcd. And after that, it gets a bunch of stuff. It also interacts with AWS, so I have instrumented the AWS SDK to be traced. So every time that I get a call to AWS, I know which action I'm doing. So I'm describing a subnet in this case. And I'm also logging the body of the request. Obviously, you need to be careful about what you do. But in my case, this is a scheduler, so it doesn't have a lot of traffic, but I need to be precise and have a lot of information when something gets wrong. So that's why I'm logging request and response and whatever I can, because it helps me. It helps me. Obviously, tracing can also be used if you work with AWS or with other API. You probably know that you have sometimes you get back a request ID. And usually that request ID can be looked up as a trace. So with the support team and with our customer, we are also teaching them to remember the request ID and told us the request ID when there are problems. This is very good feedback look back because they get the request ID when it fails and they give us, okay, this doesn't work and this is the request ID. So I can take the request ID, and from the request ID, I can look up the trace and debug. So that's it.
So we are good in time, so there's time left for questions, so don't be shy.
So I can have them in my slides, so please.
Okay, so no question from the room, but there's a question from me. So if I implement that OpenTrace libraries into my application like Go, how big is the performance impact on the Go daemon or the Go process itself?
It will grow, I mean, almost nothing. Obviously, depends how much data you are handling, but it works in background, so it just collects metrics. So you probably discover a little bit of spike in memory, but not that much, and it gets the trace back to the centralized server. So it's not that impact. There is not a lot of impact.
So it did not increase the load of the application itself.
No.
Okay.
No.
Here, there's a question left. So.
I have a question. So can every span add labels to the global trace? Is there a global trace that has labels, or you need to look for the labels of every span?
Can you repeat, please?
Yeah, so are there any labels at the trace level or only at the span level? And if there are at the trace level, do you need to put them when you create the trace, or can every span add labels to the complete trace?
Yeah, no, there are no labels in the trace itself. So what you can do is you use the span context, and all the spans has that label. So that's the idea.
Okay. Further questions? We still have some time? No? Okay, then Gianluca, thank you.
Thank you.
Thank you for being here.
Thank you.